Well, hello, all my beautiful students. I am making this video to help you determine the domain and range of a graph. So before we get into actually determining the domain and range, I just want to jump into a little bit of notation here so that we understand how to write our answers. So just to clarify things just a little bit, if I were to ask you to give me the interval notation for this first graph, okay? Let's see. We can tell that we start at -3. We can tell that we end at 7. And that our x's are anything in the middle. Because everything here, the -3 is a solid dot, 7 is a solid dot, and there's nothing but solid dots in between -3 and 7, which means that there's an infinite number of points on this particular segment. So many, as a matter of fact, that we can't even draw them all before they look like they're being merged together. So the notation that we use to draw an infinite number of points right up against each other like that is just a simple line segment with closed endpoints. So this means that I have an infinite number of points including the -3 and including the 7, but all these x values are in between the -3 and 7, well, all but the 2 with the -3 and 7. So -3 is less than x, which is less than 7. We always pick the small number first. We always use this bigger number second. And if we're going to go from small to big, then we're always going to use less than signs because small is always less than big. That being said, I go back and I look and see whether my circles, my points, are represented with closed circles or open circles. If we have a closed circle, then I need to have an underline here. I need to have this equal sign to indicate that the -3 is included in that particular interval as well. Same thing happens over here with the 7. Because I have a closed circle on the 7, I need an equal sign underneath the inequality so that it says less than or equal to. Now there's another way we can write this inequality. We can just say -3, comma 7, and we can use brackets. Brackets indicate a closed circle or an inclusive interval. Inclusive meaning you are including the endpoints. All right, let's move on to the right. I have a -2 here, I have a 5 here, and my x's are everywhere in the middle. All right, I'm going to use the less than symbols because -2 is less than 5. So I want any x value that's bigger than -2, less than 5. I do not want to include the -2 in my set of answers that are being shaded. So I'm going to leave this as what we call strictly less than. However, the 5 you can see is a closed circle, which means the 5 is included as part of the solution set here. So I have to put an equal to sign right there. Okay, and like the other interval notation, we can also write -2, comma 5. I will use the bracket on the 5 because the 5 is included, but I would use an open set of parentheses, which would indicate to me that the -2 is not included in the final answer. You can get infinitely close to -2 from the right, coming this way, but you cannot include -2 itself. So that would mean like -1.99999 is shaded here, but not -2. Okay. Let's move on to the next problem. And you know what? I would like to actually box these answers. I don't like that box, so I am going to eliminate that box. Let's try that one more time. Yeah, I don't really like this one either, but you know what? I'm going to slide it up, so I'm going to be okay. There we go. Now I like it. And we'll do that one more time. Give me another box here. Do that again. And just slide that down slightly. I don't like the box to actually touch any part of my answer whatsoever. All right, next problem here. I have a 4 and all of the shading is to the right. So I have a closed circle on the 4, all the shading is to the right. When you keep going further and further to the right, this is considered positive infinity. So you could give a bunch of different answers here. You could say -4, positive infinity. You can put your x's in the middle, less than symbols always, but this would have an equal to sign because this 4 right here has a solid dot. Okay, which means that the I don't know where the negative sign came from, but it's just 4. There you go. Say 4 is less than or equal to x, which is less than infinity. You could also do 4 comma infinity, and if I don't put a positive sign on the infinity, it's presumed to be positive. I like to use parentheses around all infinities, positive or negative, because I just don't seem to think that you can include infinity. But I won't take any points off if you use brackets. Matter of fact, the great mathematicians can't decide whether or not the parentheses or brackets should be used to indicate around an infinity. Some mathematicians think you can't include infinity, and others think that infinity is a concept. That means something is continuing to go and go and go without bound. And so if you're including the concept, well, then you can put a bracket around the concept, which embedded in that concept is the fact that it keeps going. So I don't know, I'm not really too concerned about it. This is another way to give your answer here. Or you know what, if you just like to say x is greater than or equal to 4, I would take that. And that's probably the way you would normally write an answer without this new notation. Okay, so let's just get that off the 4. Somewhere in the middle. Very nice. Okay, next example here. I'm now at -1, sitting in here at -1. I have an open circle, which means my -1 will not be included in this problem, so no bracket. Down here, as I move to the left, I have negative infinity on my axis. So I am looking really at negative infinity to the left and -1 to the right. The x's are in the middle, put less than symbols again, and no equal to symbol here. You don't want this here because an equal symbol right there would indicate that -1, this point right here, was a closed dot, but it's not a closed dot, so I don't want it to indicate that. And you can also use this other new interval notation when you say negative infinity to -1, parentheses around both, because neither one of those are included. Or if you just wanted to get simple, you could just say x is less than -1, and that works too. Any of those ways you can give for an answer, but any of those ways you have to understand as well. So if you like one way better than the other, that's okay, but you've got to understand when the other type of answers are given as well. Okay, 2 more examples and we'll call it a day here for this part. So in this bottom left example, I'm way over here on this, okay? I am looking at just 2 singleton points. I don't have any interval, I don't have an infinite number of points, I only have 2. So I could literally just say x equals 2 or x equals 9. And I could be done with that. Now, if you wanted to, you could, I suppose, say 2 comma 2 and wrap that in brackets. And then union, bracket again, 9 comma 9. But this really seems to be a far out way of saying something. But this is how we do indicate a single point. We start at 2 and then we include it, and we stop at 2 and we include it. So therefore we don't have any other points than just the 2 itself. So for this particular interval notation, that is how you can write that. Okay, so I'm going to go ahead and box this. Move that up slightly. I'm not on it, am I? There we go. And over here on the very last one, it looks like I want everything except that 3 value. So I would suggest maybe, let's see, we're probably going to interval notation again because I do have an infinite number of values here. So I would be, this would be negative infinity. Over here to the right would be positive infinity. I'd be looking at negative infinity all the way to 3. So my x's are in the middle there. Less than symbols, I don't have a solid dot anywhere, so I wouldn't put any equal signs. Or maybe it's someplace between 3 and positive infinity. So you kind of treat this as it's just 2 different sections. Okay. Another way you could write this would be negative infinity, comma, 3, and you would leave parentheses around each of those. Union, which just means put together with it, 3 to positive infinity. All right, and this right here, this whole concept right here, that end at 3 but don't include it, start at 3 but don't include it, this whole thing right in here, this is how we omit a single point. That's how we omit a single point in interval notation. We're given every other point that's on that line except 3. All right, well, you might be saying you're doing too much, and I agree. I think this would just be easier if you simply said x cannot equal 3, and I would accept any one of these possible combinations. I'm going to scoot this over just a little bit to tighten that up. Okay, and now we're going to box that as well. And we're going to slide that up slightly. There we go. Okay, so we have all of these different ways that we use our interval notation for. Now I'm probably going to be using this space a little bit, or maybe not. I think I'll just leave that where it is, so you can come back to that when and if you ever need to. Okay, back over here to the left. All right, I'm going to highlight what I'm talking here. My domain values are my x values. We always mention them from small to big, or since domain goes left and right, left first and then right, left to right. Range values are your y values. We still mention everything small to big, but this time, since the range is more of a vertical measurement, it goes from the bottom to the top here. I can't make that thick, but we start with low values and we end with high values. Okay, so in the domain we are looking at starting from left to right, and in the range we are starting from the bottom and going up. All right, do not give me the values backwards because it won't work that way. All right, I'm going to go through these. I'm going to see how fast I can roll on these things. We've talked about, in class, we talked about a couple of different ways of figuring out domain and range. I'm going to go ahead and just give the answer here for this. This domain is what x values belong on this function. The smallest x value that exists here, and I think I'm going to pick purple to write with. The smallest x value that's on this graph is a -8. And the largest x value on this graph is a 7. This is my -8. This is my 7. Both of them are both of them have solid dots, both points. So we have put brackets around those values. And my range, the lowest value over here is -5, and the highest value is 10. They are both included, so I'm going to put brackets around them as well. If this becomes hard for you to do, and this is a very easy example, but if it does become hard for you to do, what I want you to do is try and focus on figuring out the domain and range individually. So my domain, if I want my x's, and I look at this one point right here, and I can tell that x value is -8, I simply slide that up and plot a -8 on the graph. Every other point that's here, if I wanted to know its x value, I would simply look straight up, and that would tell me its x value. So since this is completely solid here, sliding all of these points up to the x-axis would make this completely solid all the way to this point of intersection. Now I would take this 710 point, and I would take the 7 value and drop it straight down and put a dot right here at 7, x equals 7. Every other point along here would get dropped straight down again. Every point in there, I don't have to keep drawing them, but they would all consist of these x values right here. So you can see that I'm going from a -8 over here to a +7 over there. It's pretty clear. The domain, basically, anything above your x-axis, drop it down. Anything below your x-axis, pull it up. And whatever's labeled on your x-axis becomes your domain. and it's left and right, so it matches exactly with all of those examples we just did over here. It's too bad I didn't do any up and down examples over there, but if I did, I would call them y's, that's for sure. Okay, I'm going to erase what's, no, you know what, I'll just switch colors for you. I'll just switch colors here, and we'll call this -5 to 10, like this. Okay, my lowest point right here is -8, -5. So my lowest y value would be a -5. My highest y value is a 10. And I know that because I just travel over here and there's my 10. All of these values right here, if I slide them over to my y-axis so that I can see what the y-coordinate is, every single one of these points would fill in that y-axis from the 10 down to that point of intersection, or from the point of intersection up to the 10, however you'd like to think about it. Okay, now all of this is to the left of the y-axis. So in order to read the y value, I'd have to look to the right to read that y value, and every single one of these points would be filled in. So now you can see that my y values start at -5 down here on the bottom and go all the way up to 10 up there. Okay, let's move on to the next question here. Domain. Now let's talk about these arrows for a minute because we do have some. Let's get back to my purple here for domain. I will label something in blue for a minute. This arrow right here tells me that this graph will continue to go left forever and also up forever. It's not going straight up. It's got some kind of a stretch to it. This quadratic, and it is a quadratic, is going to continue to open more and more and more as we go higher and higher and higher. So this quadratic is really going left forever and up forever, kind of like an XY point. And when you go left forever, that's considered negative infinity. And when you go up forever, that's considered positive infinity. And now let's look at our other arrow, this one here. This arrow here is in quadrant 1, and the graph kind of stretches and continues to grow in quadrant 1, but it stretches to the right and it grows up. So this really means right forever and also up forever. So when I'm talking domain, right forever would be positive infinity, and when I'm talking range, up forever would be positive infinity. So we're playing around with both the infinities here, left for the negative. Alrighty, this graph does not go down forever at all. Okay, so domain. Let's get into this domain idea. Change my pen to purple. I think this arrow here, if I were to drop it down, would be right here, and it has an arrow on it, which means right forever. You see that right here? Right forever would be this arrow that I'm making bold here. This section of the graph right here, all these points would drop down and they would fill this in. The bottom section of the graph, those points go up. I feel like I lost my pen here. These points go up, so I can read my x coordinates, and that would be all these x coordinates here. And then these points will drop down just like this, and this arrow will drop down as well, and this will be an arrow pointing left forever. So the domain of this graph is actually negative infinity all the way to positive infinity, and this should be labeled positive infinity over here, right? Okay, so domain here, there's a bunch of different ways I can say it. I can say negative infinity to positive infinity. I'm going to write it right here, negative infinity to positive infinity. I could say that. Whoops, never want to write through what we have. Alright, having a little difficulty. Negative infinity, positive infinity. Or you can say negative infinity is less than x is less than positive infinity. Or you can say capital R with a bar in it, and that means all real numbers. So I'm just going to leave that capital R with the double bar. And now I'm going to switch my pen to talk about range. Range is how high and low this graph goes. The lowest point on this graph is right here at -6. I don't think anybody's going to confuse that. That -6 right there is the smallest y value we're going to see on the graph because there's nothing else down here. Okay, -6, and the graph goes up, 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 up in both directions. Well, just up, 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 up is all I can say. And so that's positive infinity. -6 is included, and there's my range. And let's talk about this. If you squeeze this graph so that everything, like this arrow right here that I'm drawing, the one that says up forever, if this comes over here, then I'm going to have an arrow that goes up forever for the y coordinate. All of these points come over here, every single one of them, every single one of them, every single one of them, until all of this is solid. And these come over too, but the fact is there's already points there, so it really doesn't matter. They're just going boop, 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 right on top of everything else. This here is an arrow as well that just goes right over on top of that other arrow. I know I made a mess out of that picture, but hopefully it makes sense. Let's see if I can do a little better on the next one here. I won't mess it up so much. Domain. Domain goes from -10 all the way to 8 with a close. So -10 to 8, close on the 8, open on the -10. Let's try range. The range here, if I want to think about it, coming over here a little bit. Okay, close at the -2. Whoops, get out of there. Not quite sure how to make that go away. Moment. Okay, it happened. Okay, so this would be a 6 right here. See the 6? This is my y value, right? Okay, these values would all come over. I don't want to mess this up though. I want to make this look kind of nice. That would get shaded from the left part of my graph. That would get shaded from the right part. When I say left and right, I just mean left of the y-axis, right of the y-axis. So my range, oh, and you see that? I brought that 6 over and I made it solid. I just wasn't thinking. I need to make it open because it's open right here. See that? So the lowest this graph goes is -2. The highest it goes is 6. Doesn't quite touch 6, so 6 is not included, but the -2 is. Okay, let's see if we can move a little faster here. Let's go on to the next one. Oh, these are easy ones. Okay, first off, this is not a function. This is not a function because I can show you an x value. Let's just say x equals -2, which would be right here. A vertical line represents an x value. So that particular x value of -2 has two different y values that it's paired with. So this is -2 comma something, and this is -2 comma something else. And we're not supposed to have the same domain element paired with more than one y element. So this is a range element, I should say. So this is definitely not a function. But we still have a domain and range, even though what we have is called a relation. So if I take the furthest point to the left, which would be this point right here, and I drop it down to the x-axis, my 5 is going to be solid. And my -5 is going to be solid. And if I take this point right here, which is the 5, 1, and I drop it down to the x-axis, the 5 is going to be solid there as well. So all of this up here drops down, makes me solid between -5 and 5. Include the points because they are definitely included in the graph. And then I'm going to switch over here. Up. I'm going to switch for my range. Range is low to high. So I'm looking at my y-axis. The lowest point here is -4. Oh, come on. Let's see if I can just trick it to thinking I'm selecting it again. -4. No, it doesn't like to be tricked. Okay, I'm back. Maybe I'm back. Lowest point is -4 for my y value. Highest is a 6. So I would end up with this. So -4 to 6, including both of those points. And I'm doing something wrong. I knew it was not blue. So I'm going to make this purple. I'm going to make that purple. Just to be consistent. There's my -5. There's my 5. There's this. And I'm going from -5 to 5. Including both of those points. So hopefully that looks better. All right, let's move on to question 5. I like question 5. Gives me a little bit of oomph to it. Okay, so domain first off. I need to think about what that's fine. I need to think about what this arrow means down here on the bottom, the one I'm just circling right here. So I want to know what that is. That means that this graph is continuing to go left forever. I think I need to just scroll up a little so I'm not touching the bottom of my screen so much. Left forever, and also down forever. Okay, left forever is like -infinity, and down forever is -infinity. So this this -7, -10 would come. Let me switch to my purple. Would come up here, and you know what? That shouldn't say -7. That should definitely say -9. So that's my bad. Okay, so we'll go back. So that's a -9 coming up here and making that a solid dot. Everything here goes up to the x-axis. Everything continuing to go up, up, up. All of this would get shaded, and this -5 value will go, well, the 4 value, because I'm talking x, right? We're saying domain, goes up here as an open circle. See, this open circle is being moved up into the 4 spot. But now I have the rest of the graph. So I've got this 4, 2, and now this solid point is going to come down, and it's going to fill in that open point. And all of these values, including this arrow here, are going to come down here. And the arrow, this arrow right here, is going to be used for the x, and it's going to be used for the y eventually. Okay, so any arrow in the middle of your graph is going to indicate 2 other arrows. Now I guess I don't have my other arrow drawn. All I did was take this -9, -10 point. I'm right here now, you guys, okay? All I did was take that value and move that up, but I didn't talk about what happens after it. So this continues in this direction. So therefore this arrow is going to go up and continue to the left. Alrighty, so my domain in this problem is, again, all real numbers. My entire x-axis is solid. That means any x value I want is sitting on this graph. Okay, let's move on to range. So I'm looking at the range here. It might be nicer if I were to eliminate a little bit of this stuff in the middle to talk about range. Just a little. Okay, so range now, and I could leave that purple there, and that's fine. Range is going to be indicated by the y values, okay? Y values that we see. And this has a y value in it, this has a y value in it. So this negative, I'll talk about this -5 first. This -5 is going to indicate this open circle right here at -5. This arrow that I'm circling is going to come this way, and it's going to indicate a down arrow, down forever. This section here is going to continue to move to the right so I can see what's happening on my Y's. And this section right here moves to the left, so it makes that solid right there. There is a big gap here though. I don't have Y values in between the -5 and the 2. So at the point 4, 2, I'm going to take this 2 and I'm going to bring this over and I'm going to read that 2. Solid, solid 2. All of these points come over. My arrow comes over, and my arrow becomes an up arrow. So do you see how this arrow that is going up and to the right, actually when I was talking range becomes an up arrow, but when I'm talking domain becomes a down arrow. Or no, shouldn't have said it. A right arrow. I drew that arrow down, and I said down, and I shouldn't have. Okay. These points all drop down, sorry. But the X part of that arrow becomes a right only. All right, so all of these are filled in here. And now my range looks like it's split. And I don't like them being split because now I got to do twice as much work. I pretty much have to do this piece of it and then that piece of it. So I am going to say -infinity all the way to -5, not including the -5. And then I have to do a union because there's a gap in the middle. And I'm going to start off with a bracket, 2, infinity. Okay, notice the 5 is not included, but the 2 is included. Notice the y, oh, -5. Notice the y equals -5 has an open circle, and I'm looking right here at this -5 having an open circle, and the 2 has a closed circle. All right, over here, let's see if we can do this. Domain is all real numbers. How's that for fast? I can do this. All real numbers. All real numbers because this arrow right here is going to give me this arrow, and it's also going to give me an arrow that goes down. I'd want to change the color of this one because I'm talking range, so it's going to make that happen. And that comes from this arrow right here. Okay, this arrow means, okay, let's try to undo that way. The yellow arrow that I drew, which maybe I should have just put it in black. Okay, this arrow right here means left forever and down forever. The other arrow over here means right forever and down forever. So this arrow that I'm tracing here and making really, really bold is going to be responsible for X going to positive infinity this way. It's also going to be responsible for Y going down, 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 down to negative infinity, which I already have from the other arrow. All right, anyway, let's move a little faster. This hump here that I have above the x-axis, it comes here. This section here down below is going to fill that in. This section down below is going to fill this in. And my arrow is going to kind of be here a little bit, maybe even a little bit shorter. It doesn't really matter because an arrow says what? Keep going is what it says. So there, my domain is all real numbers. My range is going from, let me see, down forever. Do I go up forever? I hope you say no. Okay, this range is going up, 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 up until you hit 8 with a solid dot, and then it just comes back down. Okay, but if you move all of these points that I just drew over to the y-axis, you're going to see this whole y-axis get covered like this, and your range will be from negative infinity all the way to 8. Do not include the negative infinity, but include the 8. Or if you wanted to say it, you could say y is less than or equal to 8. That's a little easier. Okay, next problem. We're just going to go kind of fast on here. This -3 is going to, oh, switch your colors, Gina. Okay, so I'm going to purple. So my -3 comes down like this. My +3 comes down like this. Everything else comes down and fills that in. I'm looking at my domain being -3 to +3. Sorry, hold on. -3 to +3, including both of them. And my range looks like the highest point is 10, lowest point is 6, and all of these points, if they've merged over to the y-axis so I could read the y values, would fill that in. So would these. Just so happens that I would have two different x values being sent to the same y value, which is typically okay, it just can't work the other way. Anyway, the range here goes from 6 all the way to 10, including both values. And once again, question number 7 is not a function because each element in the domain is not paired with exactly one element in the range. In other words, each x is not paired with exactly one y. Question 8. Oh, this one's kind of simple. If you just drop this whole thing straight down onto the x-axis to read the x-coordinates, you would get the x-axis back. It's kind of simple. Every single point on the x-axis has a point that's up there on that line. So the domain is all real numbers. Range, on the other hand, if I took all of these points here and I brought them over to the y-axis, they would go and just kind of like land right on top of themselves. Same thing with the points to the left. If I brought all of these points over to the y-axis, there's already a point solid on the y-axis, but it would still, they just land right on top of themselves. Just pile right up on top of one point. So my range in this case is simply y equals 6. And if you'd like, you could also say 6, 6 and be done with that. Start at 6, end at 6. You don't have anything else. There is only one value for y on that entire graph. Every single point you have, no matter where you want to put the point, the y value is 6. Okay. Number 9. My domain is looking like x equals -3. No. Go away. I don't know why. -3. Okay, just like all these points come down and they just slam on -3. All these points go up and they slam on -3. It's just -3. Matter of fact, that's the equation of that line, x equals -3. Just like back over here, the equation of this line is y equals 6. Okay, so now my range here, range goes down forever, up forever. Okay, if I were to move that to the y-axis so I could read all my y values, the y-axis would be completely full. The range is all real numbers. 9 more problems. I'm going to speed myself up, even though I keep saying that and I don't do it. Question number 10. My domain is going from -6 all the way to positive infinity. Oop, I almost put parentheses around that 6. Should be a bracket because -6 is a solid point for x equals -6. Okay, and everything would simply be full along the x-axis. Range, okay, I'd have this section full from all the points over here on the right coming over. Up like this. This arrow right here means right forever, which I already have this on my x value, but it also means up forever, so that means this. The bottom arrow down here means right forever, which I already know that has to deal with the domain, but it also means down forever, and that means down forever. So I am looking at all real numbers for my range. Numbers 11 and 12 are both cubic functions. Cubic functions like start low and end high, or they start high and end low, or they do something like that, some little squiggly up and down. They turn around twice usually, not always, but at most twice. Both of these are cubics. That means the domain and range are both all real numbers. But let's just look at this for a second a little more carefully. This piece that goes up in the air like this arrow means up forever. It also means right forever. Oh, that is so bad. It means right forever and then up forever. I want to use the word right first because that indicates an X movement, and then up would indicate a Y movement. So I want to say them in order properly, especially if I put parentheses around it like that. So because that up arrow means right forever, that means that I'm going to have an arrow going right forever here. These points, you slide them down and you look at the x-axis, you're looking at everything here. Same thing happens here. This means what? Left forever and down forever. Left forever is going to mean negative infinity over here, and down forever is going to mean negative infinity down this way. But that happens when I talk range, not when I talk domain. All these points come up, 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 everything gets filled in. Domain is all real numbers. Range, all these points come over, they come over, they come over, everything gets filled in, the arrow gets filled in, right, because it said up forever. Same thing happens down here, you fill these points in, you put this arrow here, why? Because it said down forever. So you're looking at the entire XY axis being filled in. Not XY, but Y axis being filled in. And X, but had nothing to do with my range. Sorry. Question number 12. We're looking at domain. This top arrow right here tells you left forever. And it also tells you up forever, doesn't it? See? Gives me a double concept. And this other arrow over here tells me go to the right forever. Alrighty. All these points will come down. Everything will get shaded through the whole entire x-axis, so the domain is all real numbers. Same concept is going to happen with the y values. So because I have this arrow here, that means down forever. I'm going to go down forever. And we already talked about this arrow here meaning up forever. All of these points can move over. All of these points can move over. And eventually this whole entire thing will be covered, and your range is all real numbers. Question 13. My domain would end up having, let's see, a closed circle at -4, right? Open circle at 8, and everything in the middle. So -4 less than or equal to x less than 8. Or, if you don't want that, you can say -4, 8, but you have to have a bracket around the -4 and parentheses around the 8. Range is going to change colors with me. I'm now dealing with the y values. So this y value, I read it over here, it's -3. And the highest one here is 6. And you can tell that all these points are going to come over, make that solid. All these points are going to come over. So you can read your y coordinate. And my range is going to go from a -3 to a 6. I want to include the 6, but not the -3. Next question. You're going to try to ignore this piece right here, okay? It was erased, but it didn't erase well enough before I made copies. So I'm looking at domain. Domain are my x's. This arrow right here is going to tell me right forever. All of this drops down, and the 3, 4 drops down, all of them drop down, and these points go up, so that -6 is solid. All of this will be solid all the way like this. This is x is greater than or equal to -6, or you could say -6 comma infinity with a bracket on that -6 if you'd like. Okay, a matter of fact, you know what? I do like it, so I'm going to write it here, -6 to infinity. x is greater than or equal to -6. I like it better like that. Now my range, my y values, we're starting at -2. Whoops, switch my pen color and get consistent. Starting at -2 and going all the way to infinity. How do I know that? Here's my -2, it's solid. All of these will be solid, making my y-axis solid. This right here is going to give me a up forever arrow, because this arrow means right forever and up forever. And all of these y values you can read by simply looking at the y-axis. So you're looking at from -2 to infinity. Question 15. The domain quickly is just 6. All these points up here, they go brrr, and they all fall on top of x equals 6. All these points down here, they go brrr, and they all fall up to x equals 6. So I can just say x equals 6, or if I want, I could say 6 comma 6, just the 6 in the brackets. That's how you indicate a singleton point. I don't like the way it looks. Okay. The range, however, you can see it looks just like the y-axis, right? You push it over to the y-axis and obviously the whole entire y-axis will get covered. So your range is all real numbers. 3 more questions. The next one is something called a step function. And this is a function because every x value has exactly one y value. So let's see what I mean by that. Right here at like x equals 7. Okay, this open circle doesn't count, but this closed circle counts. So when x equals 7, there is only one corresponding y value, and that would be the -2. All right, we definitely have a function in this case. It's called a step function. So I'm telling you, let me see, I'm going to do this kind of fun. I'm going to say, I'm going to take this segment right here that I just circled, and I'm going to drop it down to the x-axis. And when I do that, I'll have an open circle on 7, a closed circle over here around 12, and solid in the middle. And now I'm going to take this section. You see what I'm circling? I'm going to take that section and I'm going to slide it up or push it up so that it touches the x-axis. And the 7 that's solid is going to go up and it's going to fill in the hole that's there. This whole section is going to go up. Just slide it right up so you can read the x coordinates, and you'll have an open circle here. But likewise, this next piece is going to go all the way up into the air here, up until the x-axis. And I don't want to mess this up too much. Hold on. So this x equals 2 is going to go up, and it's going to fill that in. And this whole bar goes up, and it's going to fill this all the way over to -3 with the open circle. See that -3 for the x value is going up at -3? And it's open, but that's okay because I have another section I'm going to play with. And here I have a -3 that's solid. That's going to go up in here, and it's going to fill it in. It's going to be solid all the way over to -8, where I'm going to have an open circle going up in here. And now I can read my domain. My domain starts at -8, but I do not want to include it. And it's consistent all the way across until I get to 12, and I do want to include that 12. So I'm going from -8 to 12. And I have every single x value in the middle, not including the -8, but definitely including the 12. Now, range. See this section right here? If this section were to read the y value, you'd have to look to the right to read the y value on the y-axis, and the y value is going to be -10. This -3, -10 will come over here and get onto the y-axis. This, whatever it is, all of these points I'm drawing right now, they have y values of -10, every one of them, because this is a little horizontal segment. So when you move over, you're only covering the -10. Got that? There's nothing in the middle between the -10 and the -6. This -6 will move over and become a solid dot on the y-axis. All of these points to the left and right will go brrr and just fall right on top. There's a big gap here between -6 and -2. Right here. All of these are going to come over to your left to the y-axis and make a dot. Now I know you can't quite see it here, but there's nothing under that purple line, okay? I remember making the problem up. There was nothing on top of the x-axis, so it's not like I covered it up. So now I'm going to take this next piece and I'm going to take the 12, 2, and I'm going to read the y value just by coming over here. Yes, I know I can read it by looking right there, but there's the 2 that y value is represented by, and this y value, and any other y value that's in here. They all have a y value of 2, so all of them come over and they go broop. So the range is y equals, the lowest one is -10, then -6, then -2, and then 2. Just singleton values. Question 17, I think I can do it right here. Domain, I'm looking at all real numbers. Why? Because this arrow says down forever. I get you, but it also says left forever. And this other arrow over here, right here, this one says down forever as well, but first it says right forever. All of this is obviously coming down like this. And these go up, 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 and they continue to go up, 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 because this continues to go down, so these continue to go up. Okay? Alright, I hope so. That's all real numbers. Range. Range, I'm looking at, these are down arrows, aren't they? So -infinity all the way up to 8, and we're going to want to include the 8, but not the -infinity. So that would look like this for your y-axis. Okay, let's go back to the last one. Let's see, closing off the x-axis is pretty simple. You just drop this curve down and you end up with this. So this is -infinity. I'm looking at -infinity all the way to 6. I have a close on the 6 because that's a solid dot right here. Solid dot. Okay. And my range means I got to go up and down. This 0 right here is the lowest this graph is going, which means this 0 is going to move over here and fill in that 0 right there. Okay, as I move up, doesn't this arrow tell me to go left forever, which I already know from there, but doesn't it also say go up forever? I know I'm going left a lot faster, but it does continue to rise to infinity. So my range is going to start at 0 and go to infinity. Include the 0, not the infinity. Or if you wanted, you could just say y is greater than or equal to 0. The previous one, number 17, we could have said the range is y is less than or equal to 8. It's kind of easy. Okay, so you have 18 examples. You got almost an hour here. I took my time. I drew pictures. I color-coded for you. Everything is consistent. There's a lot. Look at all this work. Look at all that. Oh, we didn't do very much at all, did we? It's just right over there. Okay. Anyway, that's all I really have to say for now. I hope this helps you. And I would be amiss if I left without saying this. Let me see. You ready? Let's go for a cool color. How about that one? Okay, so we have to say it. We have to say talent out. You have to imagine me dropping the mic. Boom. Bye, guys.